Hey y'all, it's your math teacher, Mr. Boyd, and I'm back at it again. And today we're going to be looking at some applications of our learning so far in this unit, and we're going to talk about how to find trig functions of any angle. The previous video was sort of a precursor to this one, leading into how we're going to look at the trig functions of any angle by drawing pictures. Okay, the first thing I want to make clear is that even though we haven't used the calculator hardly at all in this unit so far, there are times in trigonometry or in applications where it makes a lot of sense to use a calculator. Okay, and so we have some examples here in the beginning. If you're asked to find something and it's cosine or sine or tangent, any of the functions of some decimal angle or an angle that's not on the unit circle, a lot of times that makes a lot of sense. So in that case, we can just type it in as is. So I'm going to type that in now. Cosine is 7.2, and I get 0.99. Okay, so P equals 0.99. Okay, that's totally fine. What about here? It would make sense in this case, especially if that's not a whole number or fraction. Often when it's given as a decimal, it's appropriate to type it in a calculator. Not always, but often. So in this case, I can just type in sine inverse, because inverses are used for finding angles, of 0.8, and we'll see what I get. Looks like 53.1. And I'll need to interpret that. My calculator's in degree mode, so that's going to be degrees. And what about this last one? This one just has one extra step. We'll need to divide by 8 on both sides before we can type it in. And then it's tangent inverse. Make sure you hit inverse. And then also make sure you put 15 over 8 in parentheses. If you don't type this in parentheses, your calculator is very likely to misinterpret it. So be careful. I'm typing that in now, and it looks like that's probably, I'm going to round it to a whole on this one because it's really close, 62 degrees for theta. Okay, so keep that in mind as we get into some applications. Let's start with a pretty basic one. Okay, let's say that we're going to walk down a hill. It's a 100-foot high hill, and so I'm talking about elevation loss in that. It takes us 127 steps, and each of my steps is 3 feet long, and we want to find the angle of elevation of the hill. Okay, so I'm not going to draw actually a hill. I'm going to draw a triangle because I'm really good at doing math on triangles, and hills can be understood in this context as a triangle. So my hill is 100 feet. And this is, I'm walking 127 steps. I'm putting it up here because I'm not walking underneath the hill. I'm walking on the hill. So not feet though, that's steps. Okay, and the first thing that should jump out is, uh-oh, those units are not the same. So we need to probably make them the same. They said each of my steps is 3 feet long. So that would just be 127 times 3. That would be 381 feet. Oops, feet. Not FF, feet. Okay, and then they want to know the angle of elevation of the hill. That's this little guy right here. Okay, and they asked for it in degrees. My calculator's in degree mode, so it looks like I'm ready to go. Okay, it looks like this is probably a tangent question because I have opposite and adjacent. So I'm going to start just setting this up. Tangent theta equals the opposite side over the adjacent side. And that appears like I'm ready to type that in. So it's going to be tan inverse because I'm finding an angle, or inverse, excuse me, tan inverse. And then I'm typing in 100 divided by 381. And 14.7 degrees is what I get. Okay, so that's kind of like a simple introduction question. That's the kind of thing we probably could have done in our geometry class. Now let's get into a question that may have been a little bit challenging for the geometry days. Here it is. We're traveling in a boat, and we notice a bridge in the distance, and we look at it at an 11-degree angle to see the top of the bridge. After traveling another mile toward the bridge, we can now see the top of the bridge at a 23-degree angle, and we have to determine how tall that bridge is measured in feet. All right. So at this stage, we should do what we almost always need to do on a story problem. We should probably always try to draw it. Guys, I'm going to suggest that you pause here and try to draw it and see if you can get something that represents the situation. Okay, here's how I draw this one. I'm going to look from a boat. Here's my boat. And I'm going to look at the top of the bridge at an angle of 11 degrees. I travel 1 mile forward. So this distance right here is 1 mile. I travel 1 mile forward, and now I look at the top of the bridge again. But now it's at an angle of 23 degrees. And I have to say how tall the bridge is. So I'm just going to call that x. That's what I'm trying to find. All right. So it looks like maybe, or you know, actually I'm going to call that h. Let's do that. So it's actually height. So this looks like it might be a little bit challenging. It looks like there's not enough information, doesn't it? Well, actually there is. Okay, we're going to have to be a little bit creative. I'm going to call this x, and that's why I switched that from h, because I want x to be something horizontal. And what I'm going to try to do now is I'm going to look at this question one triangle at a time, because guys, notice there's three triangles. We have an obtuse, a right triangle, that is a right triangle, and then we have a third, or another right triangle that's the whole entire picture. So I'm going to focus just on the two right triangles. Let's start with the smaller one. Okay, the smaller one, I have the adjacent and opposite labeled, so I can do tangent. So tangent of 23 equals h over x. Okay, and it looks like I have two variables, so there's not a whole lot that I can do with that. So now I'm going to look at the bigger triangle, this bigger triangle, basically the whole picture. And so on that one, I'm going to do tangent again. And so this time it's tangent of 11 degrees, and that equals the opposite side h. And then I've got this side here. Okay, so I got to decide how long that is. This is my adjacent side. That's 1 plus x. Okay, now, there's another consideration that we might want to make here. We were asked to say how tall this bridge is in feet. And so, as I'm looking at this, I notice that I'm actually using miles right now. I think I'm going to convert now while I'm not going to have to do any rounding. So I'm going to make that 5,280 feet. And then I'm going to come back over here and I'm going to change that 1 into a 5,280. That way at the end, I don't have any additional unit conversions or rounding or anything like that. I'm just going to be done when I get my answer. So 5,280. Now, both of these calculations individually look like they're kind of a dead end. I mean, I've got two variables here and I got two variables here, but you should know from your previous algebra class that if you have two equations and two unknowns, there's almost always a way to solve that, or at least determine if it's solvable. And that's going to be no different here. So what I'm going to do, I'm going to zoom in so we can see the calculation. We're going to focus on the algebra for just a minute. Okay, my move on these is I'm going to multiply by x in this one. And so those go away. And then over here, I'm going to multiply by 5,280 plus x. So 5,280, oops, don't forget the 0, plus x. And over here, same thing, times 5,280 plus x. Let's rewrite that and see what it looks like with the dust settling. Okay, so I get x tan 23, redo, x tan 23 equals h. And over here, I have 5,280 plus x times tan 11 equals h. Okay, and again, this may not look very promising, but notice, right here, this stuff is equal to h. And over here, this stuff is also equal to h. So guess what? If this is h, and this is h, then these two things are the same. So now I'm going to be able to combine these two equations together and say x tan 23 equals 5,280 plus x times tan 11. And so why is that valuable? Well, that's valuable because I'm able to eliminate one of the variables. This equation on the left had x and h. This one had x and h, and now I have a new equation that does not have both x and h. It just has one of them. And so now we have something that we can solve. So let's try it. And we're going to continue with the algebra steps here. Okay, what I'm noticing, I have x in two different places. I don't find that to be super helpful, so I'm going to distribute this in and hopefully get all the x's onto one side. So what do I have? I have x tan 23 equals 5,280 tan 11 plus x tan 11. I'm going to subtract the x tan 11 over to the left side, so all my x's are on the same side. So I have x tan 23 minus x tan 11 equals 5,280 tan 11. And why is that useful? Because now the two terms on the left both have an x in them, which means I can factor x out. And then again, I'm leaving the right side alone. So 5,280 tan 11. Okay, and that's not parentheses, that's a 1. Okay. All right, and then I can divide out the tan 23 minus tan 11. So here I go with that. Tan 23 minus tan 11. And now that x is alone, it's actually calculator time. The only thing I want you to be careful of when you type this in, make sure you have parentheses around that denominator so there's no confusion there. So 5,280 tan 11 divided by parentheses. tan 23 minus tan 11. Close your parentheses, and let's see what we get. I get 4,460, and let's round it to 0.46. And remember, since we converted to 5,280, this answer is in feet. So, is the bridge 4,460 feet tall? No, probably not. Let's zoom out and see what this means in context. Okay, we now know that x is 4,460.46. So I'm going to come back, and over here where I had this x, 4,460.46 feet. And what were we asked to find in this question? We were asked how tall is the bridge in feet. Okay, so we've labeled that here as h, and so now that I have that, I can look just at this smaller triangle, and I notice that's the opposite side, and I now know the adjacent side, so I can do another tangent calculation here. So in this time, it's going to be tan 23 equals the opposite side over the adjacent, so 4,460.46 feet. And now I can just multiply on both sides, 4,460.46. And now I can just type that in the calculator, and I'll know what h is. So now we're going to multiply by tan 23. And I get 1,893.5 feet is the height of the bridge. Okay, so when we run into questions like this, it just requires a little bit of creativity. If we don't start with a proper picture, we probably never can figure this out, okay, for most of us. So start with a picture, and then don't worry about what it is that you're supposed to do. On this, all I did is I said, that looks hard. It looks like there's not enough information. Let's do what I know how to do. So I knew how to do SOHCAHTOA from the geometry days, so I started filling those out. We know how to set equations equal and solve them from algebra. And so then we've got a shot at being successful. Okay, a couple examples, and then we're going to be done today. Okay, so this is now the part that's trig functions of any angle. Okay. What are we given? We're given tan equals 4, and that we're talking about an angle in quadrant 1, maybe on the unit circle, maybe not, and then we have to find the value of sine and cosine. So sometimes this gets confusing because people say, oh, well, we know that tangent is sine over cosine, and they think, oh my gosh, sine theta over cosine theta, because that's tangent, equals 4, so that's like 4 over 1, so the answers are 4 and 1. Guys, one thing that you may have noticed, sine actually can't be 4. You can't have a y value on the unit circle of 4. That's not on the circle. So remember, this is just a ratio. So how do we approach that then? What we have to do, and probably the easiest way to understand this, is to start it like this. We could say we remember that tangent is opposite over adjacent. So opposite over adjacent equals 4. Since we're in quadrant 1, I'm going to draw my triangle out like this. So it kind of looks like it's going out into quadrant 1. If that's like an arrow, it's going out into quadrant 1 of the unit circle or of the Cartesian plane. And so I now can set up a triangle that has that relationship holding. It's not that sine and cosine are that, but that relationship of 4 to 1 holds up. So if that's theta, then opposite is 4, adjacent is 1. If I wanted to find sine, SOHCAHTOA, that's opposite over hypotenuse. You go, but wait, but it's a y value. Y is 4. Okay, but it's only a y value when the radius was 1 on the unit circle. So it's actually more useful to think about this as like a SOHCAHTOA question. So in order to do that, we would need to know the hypotenuse. How could we figure that out? With Pythagorean theorem. So 1 squared plus 4 squared equals h squared. That's 17 equals h squared, and that radical doesn't simplify, so that tells us that h is root 17. All right, so now we can do opposite over hypotenuse. We can do 4 over root 17, and we're not going to leave that as a root 17 on the denominator, so we'll multiply by 1, and we get 4 root 17 over 17. Actually, I'm going to rewrite that. I don't think that's quite neat enough. So 4 root 17 over 17. What about cosine? Cosine should be pretty easy now that we have this diagram over here. Cosine's adjacent over hypotenuse. So that's 1 over root 17. You got to rationalize that denominator. And we get root 17 over root 17 rather, sorry. Okay? And so these are done. Again, this is another example where if we draw the picture, it becomes pretty easy math. If we don't draw the picture, it's very challenging to think about. So that's two totally different contexts now where it's made a lot of sense to draw the picture. What about this one? We may now be at a stage where you feel comfortable pausing the video. At the very least, you could draw the picture by yourself. If that's all you can do, that's okay. But maybe try to answer these questions too. I think you may be able to do this question at this stage. Okay, so here it is. We're told that we're in quadrant 3. So this time I'm going to draw my picture out like this, as if we're going down into quadrant 3, as if like this is the axis right here. I'm down in quadrant 3. Okay, and I'm told that sine is negative 1/3. I remember that sine is opposite over hypotenuse, so hypotenuse 3, opposite 1. If you want to put a negative next to it, that's fine. The negative really just tells us that we're in quadrant 3 or 4 though, because sine, that y value, the sine value is negative. And so now we're asked for cosecant. All right, well, I'll have to remember what cosecant is. Cosecant is 1 over sine theta. Well, wait a minute. These are called reciprocal functions for a reason. That just means they're flipped. So I didn't even need this picture for this first part, it turns out. If it's the flipped version of this, that would be negative 3 over 1, which is just negative 3. Okay, so that wasn't too bad. What about cotangent? Cotangent's the flipped version of tangent. Tangent's y over x, so this is x value over y value. So let's see, do I know those? I know the y value. I don't know the x value yet, so let's figure that out. I'm going to call that x because it's the x value. And then it looks like we can use the Pythagorean theorem. So negative 1 squared plus x squared equals 3 squared. So I get 1 plus x squared equals 9, or x squared equals 8. We can square root that, and that simplifies out to 2 root 2 when you simplify the radical. So that's 2 root 2. We might pause here and think for a second. Do we know if that's positive 2, negative 2? I mean, we took a square root here. So yeah, I mean, it's kind of, the algebra says that it's plus minus. But in context, is it positive or negative? Okay, notice, because we're in quadrant 3, that means our x value has to be negative. So that's a negative. So let's get back to this question then. It's x over y. We've got our x value here, left and right, y value up and down. And what do I get? I have negative 2 root 2 over negative 1. That simplifies out to just 2 root 2. All right, now we're to the stage where you can definitely give it a shot on your own. So pause the video and try this one. Similar to what we've done so far, I'm going to remember that cotangent is x over y. Remember, tangent is y over x. We're in quadrant 4, so I'm going to draw a picture that looks like it's going out into quadrant 4. I'm kind of imagining that this is related to the unit circle. I've got my angle in here, and they're telling me that x is 1 and y is 2, and we have to use our own thinking to figure out which one of these is negative. One of them is negative because the ratio of them is negative. And so we can see here, we're going to the right with 1, and we're going down with 2, so 2 is the negative one. That's a negative 2. And we're asked to find the value of tan. Well, wait a minute. Tan is the flipped version of cotangent. So this is just negative 2. I didn't even have to do the picture. Just like the past question. Sine, though, opposite and hypotenuse. Let's see. The opposite I know is negative 2. So I could fill that in. But what's the hypotenuse? Okay, we've got to do a little bit of work to figure that out. So 1 squared plus negative 2 squared equals h squared. And I'm just going to put an h there. We're calling that the hypotenuse. And I get 1 plus 4 equals h squared. So that's 5 equals h squared. So h is root 5. So I get negative 2 over square root of 5. You know by now we're not leaving an irrational denominator. So multiply by 1 in the form of root 5 over 5. And we get negative 2 root 5 over 5. And we're all done. Y'all, that's it for today's video. Hope you enjoyed it, and we'll see you next time.